Welcome to Module 12, Image Coding. After being went through audio coding, in this module we will explore the basics of image compression, including different types of compression, key techniques, and their application. These principles are fundamental for efficient storage and transmission of digital images, very similar to what we have done for the audio. Digital images are ubiquitous, appearing in photography, social media, and website. We use and send images all the time in our daily life. However, high-resolution images require a great amount of storage space and transmission resources. Therefore, there is the need of effective compression algorithms. Image compression reduces file size by removing redundant data or organizing it in a more efficient way. This involves a trade-off between image quality, file size, and computational resources, the same that we went through for audio. A key metric is the compression ratio, which compares the size of the original image to its compressed version. For instance, a 3:1 ratio reduces the size to 1/3. So now let's move into the types of image compression. And there are three main types of image compression. So the first, which is the uncompressed data. So in the uncompressed approach, raw pixel data are stored without any reduction. In lossless compression approaches, the original image can be perfectly reconstructed by eliminating redundancy without losing data. Lossless compression applies to a sequence of bits and it does not depend on the data being encoded. And the last one, the lossy compression, which provides an approximation of the original image by discarding data deemed less significant, balancing file size and perceived quality. Techniques are specific to the data to which they refer, being based on perception. Here you can notice the difference between the application of the lossy compression algorithm in the specific JPEG and the lossless compression algorithm in the specific TIFF. The lossy compression algorithm discarded several details related to the image fine definition. However, the main content is not compromised, as we can see here. Let's examine now some lossless compression technique. The first is the run-length encoding technique, which replaces sequences of identical symbols with a single symbol followed by the number of occurrences, which is great and very smart. For instance, the sequence green, green, green becomes green 3. Differently, the prediction and residual coding techniques predict pixel values based on their neighbors, encoding the residual difference with fewer bits. A most complex compression technique, lossless compression technique, is the LZW compression, which is similar to RLE since it exploits the symbol redundancy. However, it considers the repetition of some string of symbols instead of single ones. Analyzing the sequence of symbols S, a dictionary is created with the variable long substrings SSI that repeat in S. A new symbol is assigned to each substring. Each SSI is then substituted in S with the assigned new symbol. We can see here an example. In the case of images, symbols are colors. As we can understand, the dictionary needs to be stored with the image. The last lossless technique that we are going through is the Huffman coding, which is another method that reduces redundancy by assigning shorter codes to more frequent symbols. It operates in the following steps. First, computing the frequency of colors within the image and ordering the sequence. Second, creating a tree aggregating symbols and reordering the sequence starting from left. And third, continuing the construction of the following layer of the tree, like in this figure. In a tree, each leaf represents a symbol. 5, we then traverse the tree to assign binary codes. Going left, we assign a 0. Going right, we assign a 1. The maximum number of bits to encode the symbol is the depth of the tree. With this procedure, symbols can be coded with fewer bits. In the case of images, symbols are colors. The final tree is stored with the image for the coding, as you can imagine. Let's move now to a new family of compression technique, the lossy one. Lossy compression retains only the most significant information in an image, discarding less perceivable details like minor color variations. These methods often transform images into a different domain, such as Fourier or wavelet domain, to identify and prioritize essential components. Lossy techniques are application-specific and will be explored further in these next modules. Let's move to the conclusions. In this lecture, we have covered the basics of image compression, focusing on the differences between uncompressed, lossless, and lossy methods. Understanding these techniques is crucial for managing digital images efficiently. Thank you for your attention.